All right, let's take a look at this task 1.8, what comes next, what comes later. So, on these, what we're doing here is we're going to figure out how to find the next term in the sequence, write a recursive rule for the function, okay, describe how the recursive rule can be used to write an explicit function, then write the explicit function, and identify what type of function we've got. Okay, so you've got an example up there, but you want to try these on your own first, and then we will take a look at some of these, okay, see how you did. All right, so let's take a look at how this pattern is growing. So 5 to 10 to 20 to 40, okay, so it looks like, how do we find the next term? How would we find the fifth term? Well, we would double the previous term. Okay, so doubling mathematically means we're multiplying by 2 each time, right? Which tells us right off the bat it's going to be geometric. Okay, so if we look up at that example, notice they're using the function notation version, okay, which that f of 0 is the same as a sub 0, f of n, a sub n, f of n minus 1, a sub n minus 1. So you can try the function or you can use ours. So a sub n equals a sub n minus 1, and the growth is we are multiplying by 2, right? So we also need the starting number, the a sub 0, so if we went backwards 1 to the 0 term, it would be half of 5, so 2.5. Okay, so then to find the nth term, okay, notice how they say we start with 5, then add 3 n amount of times. Okay, so that's kind of basically the same idea. Where did we start? Well, we start with 2.5. Then we're going to double or times by 2, so times by 2 many times, or n amount of times. Okay, then when we write that as an explicit, a sub n equals 2.5 times 2 to the nth. Okay, and it is geometric, so that's kind of all we got to worry about here. Let's look at function b now. Okay, again, you should be trying these on your own first. So let's take a look at our pattern and how it's growing. Negative 8 to negative 17 to negative 26 to negative 35 to negative 44. So it looks like we are subtracting by 9 each time. So how would we find this next term? Well, we would subtract 9 from the previous term. Okay, and if we're going backwards to the 0 term, that would be a positive 1, because 1 minus 9 would be negative 8. So a sub n equals a sub n minus 1 minus 9, and a sub 0 would equal positive 1. So to find the nth term, what do? We start at 1, then subtract 9 n amount of times. Okay, explicit rule, we would then go a sub n equals 1 minus 9 times n. Okay, and because we're subtracting repeatedly, that is definitely arithmetic. Alright, so we've got 4 more to look through, so let's just jump into it again. Pause if you haven't already done it. Alright, so let's take a look at function c. So we should be able to see that our pattern here is multiplying by 3, okay, which would make it geometric again. Okay, going back to 0, it would be 2 divided by 3, so we'll just write 2/3. So to find the next term, we just multiply 3 to the previous. Okay, recursive, a sub n equals a sub n minus 1 times 3. A sub 0 we found out was 2/3. So to find the nth term, we start at 2/3 and multiply by 3 n times. So explicit a sub n equals 2/3 times 3 to the n. Alright, function D. Looking at this one, 3 to 15 to 27 to 39, we're adding 12 each time. Okay, so definitely arithmetic. Okay, going backwards to the 0 term, it would be a -9. So to find the next term, we simply add 12 to the previous. So recursive rule, a sub n equals a sub n minus 1 plus 12. And a sub 0 equals -9. For the nth term, we start at -9. Then we add 12 n times. So a sub n equals -9 plus 12 times n. And like we said, it was already arithmetic. Okay, so function E, 3 to 4 to 7, so we're adding 1, then adding 3, then adding 5, then adding 7. So this is neither arithmetic nor geometric, okay, because we're not adding by the same number and we're not multiplying. But do we know how to get to the next term? Yeah, we simply just add the next odd number to the previous, right? Okay, so can we think of how to do this as a recursive? We probably could, but because it's neither, we're not going to worry about that, okay, or the rest of it. Alright, function F. So if we look at this one, we've got start at 10, go to 2, then 2/5. Okay, so in this one, we're actually dividing by 5 each time. Okay, or, in other words, timesing by 1/5. Okay, so to get to the next term, we divide by 5 to the previous. So recursive, a sub n equals a sub n minus 1. And we can write divide by 5. Then a sub 0 will equal, well, going back to the 0 term, it would have to be 50. So to get the nth term, we start at 50. And we can say divide by 5 n times, but we'd be better off saying n times by 1/5 n times. So we'd go for the explicit a sub n equals 50 times 1/5 to the nth power. And it is definitely geometric. And that's all we need to do, guys.